Lesson 10.6, Video 2. Determine whether the two triangles are similar. So again, paying close attention to the directions, we are not told that these are similar shapes. We are told to show or to determine if they are similar or not. Now again, we know that if we are told they are similar, then we can conclude that the angles are all equal but the size is different and the sides are proportional. So those we can do the converse then and say, if we have two shapes and we show that the sides are proportional or that the angles are equal in measure, the corresponding angles are equal in measure, then we can say or conclude that they are similar. So we're looking at these pictures saying, are the angles the same? Are corresponding angles equal? Or are the sides proportional? Now in the first example, we are not given any side measurements, so we're not going to be able to rely on making a proportion. We're going to have to rely on angles. So when we look at this shape, we have to notice what is given. Well, we notice that these notations right here mean that the lines are parallel. So this line is parallel to this line. Now this is a little bit of geometry here, so a little insight and view to what's coming up with geometry. But when you have two lines parallel, and you take a line that intersects both parallel lines, well, that's called a transversal. So we have two different transversals here, two different lines cutting through those blue parallel lines. And what that tells us is, one of the rules for geometry is that when you have a transversal cutting through two parallel lines, angle B right there will be equal to angle P right there. Those are called alternate interior angles, and they are equal in measure. That would mean that angle C and Q are also equal in measure. And angle R is the same angle on both directions, and when you have two lines crossing, those are called opposite angles or vertical angles, and they are also equal. Another way to look at this is to say what angle looks like the biggest one. And if you looked at it that way, you'd say, well, angle C looks like the biggest angle in the triangle, so that must match up with angle Q, and that's one way to start as well. But again, the parallel lines is the way for us to state that they are actually equal. Those angles are equal in measure, so you can say that yes, these are similar triangles, and it's because of the angles. So corresponding angles are equal, and that's our reasoning. In the next one, notice we are not given any angles or parallel lines to help us figure out angles, but we are given side lengths, so we're going to work on proportions. Now it's important to look at this picture and see that there are two different triangles represented. Triangle EST with side lengths 25, and here we have a side length 20, but we can figure it out. If this is 66 and this is 36, then we can subtract those two and get this missing piece right here if we want, and that would be 66 minus 36, which would give us 30. Now we may not need that piece of information, but we have it available, so we'll write it down. We also have another triangle, which is the bigger one represented, and the bigger one has side length 44. The bottom one is the sum of those two pieces there, so this would be 55, and the top one is given as 66. Now again, these triangles are similar if the sides are proportional. So let's make our proportions and see what we get. We have 30 would correspond to 66, and would that be equal to 20 corresponding to 44? I'm just matching up by visual here these sides that seem to match up. If I cross multiply, I get 1,320 equals 1,320. So yes, we get a true proportion. And this ends lesson 10.6, video 2.